This is a conversation with Dan Mantz, who is the CEO of the Robotics Education and Competition Foundation, also known as the REC Foundation, which is a nonprofit that works with VEX Robotics to build interest in STEM-related career opportunities. In this interview, Dan reveals that he sees a problem. We have a large labor shortage for technical positions. This includes engineers, but also more vocational roles like technicians, and this shortage might get worse. So Dan and the REC Foundation are working to expose students to STEM through robotics competitions. These competitions balance difficulty, how much they appeal to students, how easy they are to facilitate for the schools, and the cost of the equipment so that they can be as widely available as possible. It was great talking to Dan, and I learned how he and his team are trying to pragmatically solve the labor shortage through education. And I think their mission is important. Also, it was surprising to me to learn how their program really helps students to learn soft skills, such as working on a team and problem solving, almost as a byproduct of the students participating. Yet, Dan says that those soft skills are one of the most valuable things for students to learn in their careers, whether they stay in robotics or do something different. I'm Audrow Nash. This is the SenseThink Act podcast. Thank you to our founding sponsor, Open Robotics, and now here's my conversation with Dan Mantz. Will you introduce yourself?
Hi. First, thanks for having me on today, but my name is Dan Mantz. I am the CEO of the Robotics Education and Competition Foundation. You'll hear me say REC Foundation throughout the course of the discussion, and we're based here in Greenville, Texas, about 45 miles east of Dallas. So you'll hear me just say we're in the Dallas area, and we're one of the largest not-for-profits for STEM education with a specialist on robotics and drones and workforce development.
Mm-hmm. Can you give me an idea of some of your competitions that you guys host?
Absolutely. So our largest competition, what we're most known for, is the VEX Robotics competition. And that was launched over 15 years ago now. We're 15 years into the VEX Robotics continuum. Mm-hmm. It started basically as a high school, middle school program, but it's evolved into so much more. So we call the high school program with the metal parts and the larger motors, that's VRC. We also have a very, very popular middle school and mid-elementary program called VEX IQ. Mm-hmm. That's our fastest growing program. It's even larger now than our VEX Robotics competition, our VRC program.
Interesting.
For early elementary, we have VEX Go, mm-hmm. which is a fantastic, really great program that we developed and released during the pandemic for students to really, start learning how to build things in programming. There's VEX 1, 2, 3 for K through 2. And then unlike so many other robotics competitions out there, we actually have a university program called VEX U. Mm-hmm. And that draws students from across the world, both 2-year and 4-year colleges. Mm-hmm. Also, another competition we launched last year is VEX AI for artificial intelligence competition. Mm-hmm. And that's where the robots use cameras and GPS sensors, and they do everything without manual driving. Outside of our VEX Robotics competitions, we run the robotics competitions for Skills USA and for TSA. Mm-hmm. We also run Bell VRC, which stands for Vertical Robotics Competition. So Bell Helicopter, based here in Texas, we run their competitions. We have some RAD competitions. We call it RAD-C, which stands for REC Foundation Aerial Drones Competition. And then one of my favorite programs that we run is our factory automation competition. And that's where students build conveyors and robots that simulates a distribution center. Mm-hmm. So we do the full spectrum of mobile robotics. That's the VEX platform. Aerial, which is the Bell helicopter, and then our drones, as well as workforce development with our factory automation competition.
Mm-hmm. That's quite a lot. How large are you guys?
Yeah, it's interesting. So a lot of people haven't heard of the REC Foundation, or they just think VEX Robotics. But we're actually in 80 countries. Mm-hmm. We're in all 50 states. Pre-pandemic, we had 30,000 teams just in our VEX programs.
That's awesome.
And but between our online education and our coding programs, we reach over 1 million students. And, the pandemic didn't really slow us down. It caused us to look at things a little bit differently, but we put a lot more emphasis on virtual and remote. But we do believe building robots and building drones is a key to what we do. So we actually still continued through the pandemic. We had real competitions, but we developed a technology called live remote competition, live remote tournament. And students still built their robots, and we connected students from different places across the world, and they still competed. Of course, we had to modify the game, but we persevered through the pandemic, and we continued to grow. So I have a staff of 50 in the United States, full-time employees. We have another 30 part-time employees that help us run competitions. And then internationally, we have a team of 6 regional support managers based in different countries that support our international competitions.
How do you get funding? So like that's a lot of people too.
Yes, it is. We're an interesting model. It's kind of like what I call a museum model, right? So we have multiple revenue sources, which is really good for us. So our largest revenue is actually from our registration fees. So VEX Robotics team will pay $150 for the first team, and then if they have multiple teams in the organization, it's $100.
Oh.
So if you're talking 30,000 teams, you can do the math. We also get a lot of corporate sponsorship. Northrop Grumman Foundation is our presenting sponsor, but so many of the names that are big supporters of our program. Google, Dell, Texas Instruments, NASA, Tesla, all those organizations and many, many others give us funding to keep our programs going and to grow our programs. And then we're also get government funding too through grants. So for example, we were the recipient of Advanced Robotics and Manufacturing grant, an ARM grant out of Pittsburgh that helped us develop our factory work cell competition. We get money from the Department of Defense for growing programs. For example, in Hawaii, we have a grant right now to grow programs in Hawaii, and we get a lot of state funding. So for example, in Texas, we're recipients of the Texas Workforce Commission that helps us grow competitions and teams in Texas. So it's not quite a third, but it's definitely 3 different revenue sources between government grants, corporate funding, and team registrations.
Team registrations. And team registrations are the like student teams registering to compete in the challenges, right? Or the competition?
Absolutely, yeah. So we keep our price entry really, really low compared to some other programs out there. Again, it's $150 for that first team, and probably about 70% of our teams compete. They're extracurricular. Over half of them are tied to schools, but we also have teams that are tied to Girl Scouts, for example. We have a great partnership with the Girl Scouts. So we have Girl Scout teams, and we have private club teams. We even have homeschool teams. And then another growing trend in this industry is robotics is becoming more and more integrated into classroom science and engineering programs. So a lot of times we see this in Nevada, for example, they don't meet extracurricular. They actually have the robotics team as part of their classroom.
Oh, I love that.
And so, but to compete in our program, you do have to register. That covers the overhead of running the programs. But we actually don't charge for the events that we run. We actually have a network of volunteers called event partners, and they run the events on our behalf. We're the overseeing organization. Think about Little League, and our event partners will charge a token amount anywhere from $35 to $100 to run an event, and then they keep the revenue. So over the course of a year, we'll have 3,000 robotics competitions. We'll have hundreds of drones competitions. And then with like our VEX Go program, we'll have many, many in-class challenges and competitions.
Yeah. Wow. That's nuts. How does it work with countries? So you mentioned a lot of countries are doing this as well. And you mentioned most of the sponsors, maybe it's just the ones you mentioned are US based or US government and this kind of thing. How does it work with other countries outside of the US?
Sure, absolutely. So we still, as the REC Foundation, we still have the same rules for the challenges and games and stuff like that, but we use our support outside, and they will collect registrations if they're allowed. For example, in China, we have 4,000 teams in China, and they actually don't pay a registration fee. It's covered by the government, for example. But at the end of the day, the teams still register and they still play the same game. And then our competition model is you start locally, a lot of local competitions, and then you'll go to a regional level and a national level. But they're playing with the same rules, the same game elements. And that's what's so popular is it culminates in our World Championship, which is actually being held in Dallas in May. It's the VEX Robotics World Championship, where 3,000 of the top teams from across the world come together. We have 4 different competitions, and each competition will crown a world champion.
That's awesome.
But the funding, too, you do bring up a really good point. As we talk about, a lot of times we talk about our global sponsors. But each country, each state, even every town will have a sponsor. And here's a good example, Honda. So Honda is technically not a sponsor of the REC Foundation, but Honda does so much for VEX Robotics programs in Ohio. And so they give to local chapters and they sponsor teams. TVA, Tennessee Valley Authority, while they also are a sponsor of the REC Foundation, they do an incredible job of giving funding, giving equipment to teams in the Tennessee Valley area. And internationally, for example, Shell, ExxonMobil, those companies will sponsor teams and programs. Matter of fact, pre-pandemic, I was even in China, sponsored by Alibaba. So if you don't know, Alibaba's like the Google of China, for example, or excuse me, Amazon of China, and they actually funded the national championship there. They brought me over. So but we shouldn't even forget about the mom and pop stores too, the Subway shops, the pizza shops, the local gas station. They all fund teams and stuff like that. So it's a huge ecosystem of how teams get funded. And it's emerging too. I mean, right now it's not just private. It's schools are really investing in these type of programs and putting more and more of their budget into in-class and extracurricular robotics competitions.
Yeah, gotcha. It's amazing to me, your reach with this, how far it's going. And with a staff of only 50 people, and then 30 that are part-time and this kind of thing, and then you have the volunteers. How does it, so from your perspective of actually running this and setting this up and having this big reach, what do you guys do? Is it like you're setting the standards or you're creating the curriculum, or how does it work?
All of the above. And it's interesting because I'm glad you appreciate what we're able to accomplish with just a small staff. It's matter of fact, sometimes I think I've stretched our staff tooth and I've pushed us too much. But it's the model that we chose, and the model is to rely on volunteers and partners that aren't on the payroll, right? And but what we do, a lot of teams say, hey, what do I get for my $150, right? What do I get for my $100 registration fee? So primarily one of the most visible things we do is we work, for example, with VEX Robotics on designing the games every year. So the IQ program has the VEX IQ Challenge. The VEX Go program has their little competition, and then the VRC competition. So a lot of our staff are spending their time to develop that game and develop the resources. It comes with manuals. It comes with videos. You have to support it. So that's one of the things that we do. We also work with our event partners to help them run good events, and that's where a lot of our part-time employees come in. So we have a series of team engagement managers and event engagement managers that support competitions in the United States, and then we have regional support managers internationally, and they work very, very closely with our volunteers to make sure that they run events that meet our standards. So again, I think a good model is if you think about Little League. The Little League Association sets the rules, but each local level runs their own baseball camps, right? So we kind of do the same thing. But we're very important. One of the things that distinguishes us from other programs is we really believe in student-centered. So we're not a program that encourages the parents or coaches to do the work. Matter of fact, in our program, our code of conduct and our student-centered policies is about the students doing the work. It's not about building the world's best robot. It's about learning engineering and problem solving and communication skills through the students doing hands-on work. So a lot of my staff, our team engagement managers, our event engagement managers, they're working with the coaches and the event partners to make sure that we follow the ecosystem. And like any organization, of course, we have accounting, we have marketing, we have development, we have those infrastructure too. I pay my staff, we try to pay competitively, and we give our staff free healthcare, for example.
Wonderful.
And so we have an HR department. So we have all those types of things that a standard business has too.
How does it, well, can you tell me a little bit about being a nonprofit with that?
Sure. So I personally come from the for-profit world. My entire career was for-profit. I joined the REC Foundation board over 5 years ago and ultimately ended up as the CEO here. But I didn't have a lot of experience, so I'm learning too. But a not-for-profit still has to pay their bills.
Definitely.
We still have to generate revenue, provide value, and pay our bills. But being a not-for-profit, what it allows us to do is get those foundation donations. For example, the Northrop Grumman Foundation, our largest presenting sponsor, and allows us to get those government funds. But we have to show due diligence. We have to show the funders of our organization, whether it's the government or private, that we're good stewards of their money. So again, we have probably spend 4,000 hours a year between audits and reporting and stuff like that. So like anybody familiar with any business out there, we get revenue in, we have expenses, and at the end of the year, the board that I report to expects me to bring in more money than I've spent. But then we have to account for that money to the people that fund us.
How do you think of profit versus nonprofit in this?
Well, I think that's a great question, and actually one that I've never really been asked before. But I think the challenges of a not-for-profit is there's an expectation that you can do things cheaper. So there's an expectation you can hire people cheaper and something like that, and that's not true. If we want to be the best STEM education and robotics not-for-profit out there, we still have to pay competitively. But because we don't have just a customer buying our product that basically tells us whether we're successful or not. We have so many different customers in our program. I mean, primarily for us, the students and the educators are our primary customer. Our programs are for them. So that's who I'm trying to please first. But we also have to make sure that if we get federal money, that they're satisfied with how we're spending the money. If we're getting corporate sponsorship, we're doing the things they expect us to do. And I think that's the big difference. So I was president of a company called Rack Solutions. We made infrastructure products for data centers, primarily sheet metal products. And if I came out with a new product, if Rack Solutions came out with a new product and it sold, we knew it was successful. That was our answer. And if it didn't sell, then we made a bad engineering or sales decision. For a not-for-profit, it's not so black and white, right? So I can have a program that the students love, but if the coaches and the teachers don't like it, it's not a success. I can have a program that the funders think is excellent, but if nobody wants to do it in their schools or extracurricular, it's not. So the complexities of your customer. I'm sorry,
you have to satisfy all of the parties involved.
Yeah, and that's the challenge. People ask me, is it easier to run a not-for-profit? You don't have this pressure of like having a return on investment for, like a stockholder. I'm like, no, it's actually for me much more difficult to run a not-for-profit.
Yeah, I mean, so I've been involved with, like when I was very involved with RoboHub, which is a robotics news organization, we were a nonprofit. And so I feel like I've been through some of the like pain of being in a nonprofit, but I think you can do a lot of good work and not be accountable to not necessarily have the economics drive the mission of the thing. But can you tell me kind of like why not go for profit for this kind of thing?
Well, I think the biggest reason is we don't want to become a for-profit is because I want to be able to just break even for one thing for the year. I don't want to have a return to shareholders. So that really allows us to keep the prices as low as possible and maximize value for our customers. So that's one good reason. So we had the difficult decision of raising our registration fee after 5 years. We'd gone 5 years without raising registration fees. But if you're reading the news, you know how bad inflation is right now. And that affects us too. Insurance costs are up, the gasoline, everything. So we had to raise our registration fees for the first time in 5 years. But because I am just trying to break even, it wouldn't have been as large as maybe if I was trying to maximize revenue for shareholders. But then again, also being a not-for-profit, there's great companies out there, Google, for example, that really invest deeply into our programs for the underserved community, for Title I students, women in STEM, et cetera. And that's another reason to stay as a not-for-profit, because these corporate sponsors will really invest in you if you're doing something that they feel is going to help them out the long term too. Our corporate sponsors are amazing. When NASA invests in us, it's because they want that next generation of people developing the Mars rover mission, for example. When Tesla invests in us, it's because they want that next generation of workers for their new truck factory in Austin and for the Gigafactory outside of Reno, Nevada, right? So they're about us developing the workforce, and NASA's about developing the engineers, and TI, Texas Instruments, about the next generation of computer scientists. And that allows us as a not-for-profit to better serve those funders of our programs.
Awesome. How does it, so how do the different competitions compare? So when you have the young elementary school students, or you have the middle school or high school, how do these different, and university as well, how do these different programs and different challenges compare?
Yeah, that's a great question. And in a sense, they're a progression. A word that I like to use is they progress. So if you're doing VEX Go, you still have a challenge and you're still building.
Is it the first one?
I haven't memorized the order yet. Is our first competition. So that's third and fourth graders is the primary
audience. So it's
audience.
Go, IQ, RC, and I don't remember what the university one is.
So we'll technically have 1, 2, 3. That's an entry-level programming K through 2, but we don't have a competition for that. But we have in-class activities. Then we have VEX Go, which is third and fourth graders. Again, it's simpler build, simpler programming, understand the concepts. Then you get up to IQ, and that's not a competition where two teams are facing each other. They're actually collaborating. One of the things I love about IQ is the students work together, the two teams work together to get the most points. And now you get to VRC, and in VRC, now it's a 2v2 competition, right? So now you're playing defense, and you're strategizing with a partner and how to beat an opposing alliance. And the power of the motors is bigger, and the programming. All of our competition on VRC starts with a 15-second autonomous mode, right? So the first 15 seconds, your robot's moving to score points and win the auton bonus. And then you get to VEX U, which now it's the same bigger motors, but now you're 3D printing your parts, and
that's really
there's
cool.
a lot more customization. And then you get to the AI competition, and now it's advanced programming. And now you're using GPS sensors, and you're using high-end cameras to do data exchanges between robots to solve it. So, but the nice thing about our program is if you start with 1, 2, 3, and you start coding, all that coding just grows and grows and grows, and the concepts of how you build, and the soft skills, which are so important to these programs, how you troubleshoot. I'm an engineer, by background. I worked 21 years at Fanuc Robotics, and core to the REC Foundation programs is our design process. So wherever you start in our programs, the design process of identifying your challenge and how you're going to solve the challenge and score points, and then the process of iteration of design, right? So trying something, designing something, building it, failing, and then persevering. That permeates through our entire program, whether you're at the very beginning or you're doing VEX U and AI.
Gotcha. I really like that. I feel like failing is so important, because if you don't ever fail, it's like you learn limitations and you have to work with those limitations. And you can't really make anything interesting unless you're failing, most likely. So I like that it's baked into the curriculum.
Yeah, we when I became CEO, we stepped back and we looked at our mission and vision, and we just tweaked our mission. I mean, our mission is to increase student interest in STEM by engaging students in hands-on, affordable, and sustainable robotics engineering programs, right? So we made it less wordy, but that stayed the same. But what we really changed was our vision, because for me, I wanted people to know that we want students to innovate and experience failure and persevere, right? So we literally said our vision is where students design and innovate as part of a team, and they actually fail. And in our program, because we're a year-round program, students fail a lot, but that's not a bad thing. I mean, they learn from that and they persevere, and then they become much more confident and they make the world a better place, right? And these skills, whether they go into robotics or they go into medicine or they work in marketing or they're working, as a technician, those skills, by failing and persevering, are lifelong skills.
What do you, so you mentioned mission, and the mission is to increase engagement, and you mentioned vision. How do mission and vision relate to you?
I think, first of all, one of the things if we circle back to working for a not-for-profit, one of the things I really try to do is make sure that the decisions we make in this organization are mission-driven. We have so many opportunities to go into the next great thing, but that mission of increasing student interest in STEM through, hands-on affordable robotics programs is the core of what we do. And so it's our mission. We're developing these robotics and engineering programs for our students. And it's evolving that it's also workforce development programs too. And then the vision is more captured of what we want to see these students do in the future. And that's, persevere, become lifelong learners.
Gotcha. So when you are developing these curriculum or these competitions, how do you balance like all of the different factors? So you could make it too difficult. You could make it too really, really appealing to the students, but it's like a video game and they're not actually learning anything. Or there's all these different things. How do you think about actually designing these competitions to make them engaging for students?
That's a great question, and it's a really hard process. When I joined the REC Foundation, I would have never guessed how difficult game design is, and that's what we call it. We call it game design. And so there is a game design committee. It's a collaboration between VEX Robotics and the REC Foundation for the VEX programs. It's a collaboration with NASA for the win, and REC Foundation staff for our drones competition, and then Bell and many Bell suppliers in the REC Foundation for our Bell VRC program. So first of all three programs that have competitions, it starts as a collaboration. And then you're really trying to define what your outcome for that season is going to be. But our program is a bell curve, right? And on the competition side especially, the top teams, which are the top 10%, they care about winning more than anything, right? But from my perspective as CEO for the REC Foundation, that's not what we're trying to do. We're looking at the entire bell curve and making sure that they can get something that matches our mission out of this. So we will literally design a game with an easy scoring component, right? Something that every team can do. And then we have more complex, and we want to make sure that we weight it. So what are the challenges? Even after you brainstorm games and you get it down on paper, and of course you have to design your field elements and your game elements. So you have mechanical engineers and electrical engineers that are designing this. You have to hit a cost target, right? We could develop some of the world's best games, but if it costs $5,000 for each team to buy game elements, you can't do it. So we have very strong cost elements. So you do all that, but then you start designing how you're going to play the game. And the REC Foundation and VEX Robotics, for our VEX competitions, we actually release a couple robots for different levels so that everybody that plays the game can achieve at least some of the game objectives. And that's the key, right? I'll admit we've made games that people have figured out in the first month and they've maxed the score, and we've had to tweak the rules. And then we've made some games that were maybe just a little more complex than we expected to at the beginning, but it's a team of engineers and non-engineers that are looking at everything. And also, the other thing people don't realize is that we have to think about transportation. Because we're running 3,000 competitions a year, somebody's got to go set this game up at the library or the school or the gym, different places. So we have to make sure that the game can be torn down and assembled easily too. So that all goes into it. So when people ask, like you did earlier, where's that registration fee goes to, the game design committee is 12 people, all with different roles, and there's a lot of engineering behind that, and it's expensive to develop one of these games. And we release new games every single year for both IQ and for VRC. And our drones
Gotcha.
programs too. We have new games every year for drones too.
Gotcha. So you mentioned, you said you have different robots for it. So it's like people will register their team. That happens each year, I
Hmm.
suppose.
Yes.
And then you have like different, basically, how do teams get their parts? And I think you were saying something about like different levels of robot that they can have for the competition or something.
Yeah, so one of the things about our program is we want it to be affordable and accessible and sustainable, right? So
Hmm.
once you've bought, I'm talking VEX program here, but once you've bought a VEX kit, you can reuse those parts year after year. Now there's
Oh,
some wear and tear over time. You're probably going to buy a replacement motor or two, et cetera, but use
yeah.
those parts. But you can build with a basic robotics kit. You can build a claw bot, right? And a claw bot can do a couple basic functions. What
Hmm.
VEX Engineering does every year, they also design a hero bot. And so a hero bot can play the game at a little bit higher level, right? So they're not going to be a
Hmm.
state champion or world champion, but at least allows you to execute and be successful at more of the game challenges. And then, we work with other people, and people will develop an even more advanced version of the robot for that game. But ultimately, we're not going to release a design for the world's best robot. We want the teams and the students to do that. But it's really important to understand there's a lot of clubs out there and a lot of classrooms that they're just going to compete one or two times, and they don't care
Yep.
about winning. They want the fun of going to a competition and seeing how they do, and so we want them to be successful. So that's why we release some designs, the Hero Bot, so that they can at least achieve success at certain parts of the game.
Hmm. Definitely. How do you find your price point for that? So if you're going to make a robot kit, and that robot kit you want it accessible to the majority of schools, how do you figure out what they can afford and what you can include and what you can do with that?
Well, that's always the debate, right? What can people afford? So if we talk about the game elements, that's probably an easier one, right? So every
Sure.
year, we want teams to be able to, if you're an IQ, you spend $100 and you can get that game element. So it's a little bit more expensive for the VRC program. So
Hmm.
basically, that is a limiting factor, to be honest. So any
Hmm.
engineers listening to this, they'll tell you that if you have tooling costs for these parts. There's a real cost to make these parts. You got to cover shipping.
Yep.
So it's a really limiting factor. Here's a good example. So this year's game, you could shoot balls, right? And they were more like hacky sack balls. This is in the
Yeah.
IQ. And I forget how many we have on the field. Shame on me. But say there was 24. Maybe the game would have been harder to max out if we would have had 28. But for $100, we can only afford to design, tool, manufacture, and ship. So that's like a limiting factor. Or maybe everybody in the community always wants a water game, right? Everybody always wants us to have a water game. Could we do a water game? Yes. Will we do a water game someday to the community out there? You never say never, but the price point to now have
Yes, yeah.
waterproof motors and sensors and stuff like that just doesn't make it realistic. I mean, these are high schools and junior highs and middle schools and elementary schools that are primarily buying this. So we can't have very expensive products out there.
Hmm. And what do the kits look like? Like I've seen some images and things. It's like a little similar to Lego in terms of how you make it, but like, how would you
Uh,
describe the kits?
Yeah, so let's talk about VRC first. So
Sure.
VRC is metal parts. I've always
That's
described
the
them
high
as an
school
erector
ones?
set. Yeah, this is for high school, and a lot of eighth grade, seventh and eighth grade teams that have been doing VEX for a long time.
Hmm.
They'll also do VRC. So those are metal parts with bigger motors, and I think I describe them as an erector set. So I think as generations get older, it's maybe people won't know what erector sets, but those are metal pieces that can be cut and bent and stuff like that.
Oh.
The middle school and late
And so
elementary,
it's
the IQ,
it's like a
they're
modular design where you'll have a piece and it has a bunch of holes in it, and then you can insert something in, and then you can attach
exactly it.
something to
Yeah,
that.
so for the metal pieces, you're using fasteners. For IQ and VEX Go, you're using pins. And the
Yep.
pins in VEX Go, that's the third, fourth grade. The pins are larger and easier to
Hmm.
take in and out. So IQ, there's a lot more parts, but that's exactly what they are. They're parts that you can put pins in. There's different sizes. I don't think, some people say like Lego, but the connection is so much different, and the IQ parts honestly stay together a lot better, right? You can actually build. So if you do Lego, you're not really running into stuff and stuff like that. It's more like a programming challenge versus IQ. These robots need to be a lot more robust. So, and the motors are more stronger. There's a lot more mechanisms. One of the things I always ask VEX to do every 6 months is release new sensors. So as someone who's come from industrial robotics, sensors are everything to me. And that's the other beauty of all of our programs. They come with sensors, cameras, color sensors, potentiometers, et cetera. So it's, you have to make sure that your electronics are robust enough to do the sensors and stuff like that. But that's the best way to teach coding too, is when you include sensors and you make sure that your game, you can win, you can play the game without having sensors, but you'll do better if you integrate sensors. And that's really, really important to me, is that that students that are learning this learn sensors too.
So so if a student has a robot, they've put it together, it has motors and it has a whole suite of sensors that it can access. How do they program it?
Well, one of the things that VEX has done an amazing job is they have VEX Code, and you get VEX Code for free. And I do want to say there's third-party programs out there like Pros and stuff like that you can use too. But for the simplicity, we'll just talk about VEX Code. So a lot of our students start with blocks, and then they transition into text-based programming. It looks very much like C or something like that. So it's but most of the time students will start with block coding, and when they're comfortable, they switch to text coding. And it's and then you have lots of libraries that you can bring in, the advanced programming in our programs are amazing. And same with CAD too. Even though teams start with a kit of parts, our high school teams, over 75% of our high school teams CAD up their robot and CAD the parts too. So you start at the very basic level in early elementary school, and it's a continuum. You just continue to progress.
That's awesome. For the coding, so we have the block language that kind of looks like Scratch, I think.
Yeah, I think that's safe to say that it looks like Scratch, right? And then as you move on from blocks, then it looks like Python and C++.
Okay. I imagine like a little subset of it, because C++ can be quite complex.
Yeah, it can. It's a simpler version of C++, but as someone who used to be a professional programmer, I think that
it's a good subset. You can do a lot.
Yeah, it's a very good subset. I feel very comfortable that students that are programming our robots with the C++ and Python will be able to transition that skill set outside of robotics.
How do you? So for both of these are kind of both your custom things. How do you decide to make it? I mean, so you're a team of 50 people with 30 additional people as part-time. How do you decide to go make your own programming languages as opposed to like using Scratch or using Arduino or using something that exists out there?
Well, this is the difference between us as the not-for-profit and then VEX as a product company. So, so VEX Robotics is one of the leading STEM education companies in the world, right? So we just take their products that they develop, right? So we collaborate with them. We explain what we see the needs, but VEX themselves has an incredible resource of mechanical, electrical engineers and programmers. So it's VEX that actually develops the hardware, develops the motors, and develops all the coding resources. So VEX has a division, VEX Education in Pittsburgh, and they provide some of the best products there is. For example, I would highly encourage the people listening today or watching today to look at VEX Code and Virtual Robots VR. There's free resources out there that are absolutely incredible. And again, they're free resources. And these are designed for the education market, right? So VEX is, they're in classrooms across the world. And so we're focused on the competition piece. So again, I always remind people, and VEX does the same thing. They're a product company. Their goal is to make money and sell products, and we're a not-for-profit that runs competition and camps and education activities. And we have the same thing at our drones too. So we have partners for our drones competition that design and make drones. And then we take the drone partners and we integrate them into a competition and education curriculum.
Gotcha. When you're making a competition and you are selecting the robots to use, how closely do you work with VEX to kind of get the parts prepared and get the kits ready?
Absolutely,
and this kind of
great
thing?
question. And we actually, on the game design committee, it's actually half VEX, half REC Foundation. So it's 100% cooperation, right? So we go in there from the perspective of our event partners, our coaches, our students, what they need, what parents need, what the rules, and more importantly, are we going to be able to support the competition? So that's one of our big contribution. And on the VEX side, they have the engineers and the programmers, and that's what they contribute. So it's a truly collaborative effort. And we always design our games 2 years ahead of time, right? So the game that we're going to reveal in May has been designed already for a year, and it's been tooled up, and the parts are in the warehouse, and we already have the game ready for 2023, right? So we'll start working on the 2024 game very, very soon.
Gotcha. So being 2 years ahead, does that mean you do like small groups of students that are approximately the age you're looking for, and you like run it by them and have them try it, or like early feedback, or what do you guys do?
We don't. The students from our programs that were listening would say, "Man, please do that. Please do it." At this point, security is very, very key, because when we announce our new game in May, competitions will start happening, a month later in Singapore and Australia, etc. But we have to be very, very sensitive about keeping the game private, because it is a competition. And so we actually keep the circle pretty small that's aware of the game. So some people from the RECF will play it, simulate it. Same with some of the VEX engineers. But we actually don't do any pre-testing. We also try to be flexible, just like we want our students to be flexible. So, for example, last year's game, the IQ game, we're 1 month into the season. Basically, you can lift yourself up at the end. It's called the end game. You can lift yourself up for points, and we didn't have a possession limit, and so teams just filled up, and then they lifted and dumped, and they were maxing out the game 1 month into the season. So that's where we evolve and stuff like that. We're like, okay, if you're in the air, you can only possess X amount of product, right? So, but for the most part, we try to do all our scenarios. The person who leads the GDC, the Game Design Committee, he's very meticulous in looking at all the what-if scenarios. And for the most part, we get it right. And if we make a mistake, we acknowledge it and we make a rule. And we send out rule updates at least every couple months throughout the season for clarification. A lot of times we do that for the benefit of our referees. The referees have a very difficult job, especially at the high school level, right? So we're always evolving to make sure that we're clear on our rules.
Why at the high school level is it especially difficult?
I believe that it's just more competitive. I think teams, the bell curve I talked to, there's more students at the high school that are motivated to win, So I think, the earlier, these kids that are at second and third, they're playing and they're just having fun, and they're learning STEM and they're learning soft skills, and they don't care about winning or losing. But the older you get, the more important winning and losing is. So I think our high school students are a little more crafty about finding the loopholes in our rules. So, and I mean that affectionately to you students out there, but they're definitely better at identifying and the loopholes and taking advantage of those.
That's so funny. Huh. Okay. And you mentioned a couple of times drones and the whole set of drone competitions. How does that fit? Or how does that fit with everything?
Yeah, so a few years ago, I love mobile robotics, and we'll talk about my background a little bit later. But I come from robotics, industrial robotics. But when I joined the REC Foundation, when the board asked me to join as the CEO, there's a couple things that I asked for. I said, I'll take the position, but I want to be able to move outside of just STEM. I want us to focus on workforce development. And I think there's a large set of students that aren't doing mobile robotics for different reasons, and I want to try to reach those students too. And when you look about it, drone technology is everywhere. I'm a country boy myself, and drones are used in agriculture for identifying fields that have bug infestations or need more watering or need less watering. And drones are fun. A lot of people love flying them. So we dipped our toe into drones about 3.5 years ago. And I think a lot of people honestly were skeptical. They weren't sure that I was making a good decision there. But I just felt that mobile robotics aren't for everybody. And
by mobile robotics, you mean ground robots?
Yeah,
so
ground
things
robots.
That'll just drive around. Okay.
Exactly. The ones with wheels or tank tread, etc. And so there's a whole group of students that maybe weren't going to do STEM. They weren't going to, and now also because it's fun to fly a drone, so now they start programming a drone and they add sensors to the drone or they build the drone, and they're getting that same skill set that you get in the ground-based robotics. And so that's why we did it. And then for our V5 work cell, our factory automation competition, same thing. Students out there, they're not going into engineering. They may not have the financial, ability to do it. They may not have the background, and they just may not like, school, right? So, but they need good jobs too. And robotics is the fastest growing industry, right? There's robotics everywhere. So
cool. I didn't know
we developed a program where students, they build a robot that looks a lot like a factory automation, an industrial robot. They build conveyor systems and they figure out how to make the robots work and how to collaboratively stack cargo and by color, sort by color and stuff like that. So we felt it was really important to reach all the students that we need so desperately for our workforce.
So I mean, I know that there's labor shortages and I know that we have an aging population and there's a lot of other things, but why do you say that, the last statement?
Well, I mean, just even Department of Defense and Department of Workforce Studies, we have a gap. Even a couple years ago, there was 2 million more STEM jobs being created every year than we had people to fill them. And when I say STEM, I'm not talking engineers and scientists. I'm talking robot technicians, people that are doing technical jobs in the workforce. Because even in retail now, there are technical jobs. You go into Walmart, you see the robots that are doing inventory and stocking, and you need people to maintain those. So technology is permeating themselves in all industries right now. So those jobs are growing much faster than non-technical jobs. I mean, they're growing 30% faster, and there's a huge gap of people that have the talents to do these jobs. And that's the challenge that we're trying to face. So of course, we want the next generation of scientists and engineers and technicians. I mean, I don't want to minimize that, but we also have so many students that the good paying jobs out there are maintaining the robot on the factory floor, are tweaking the inventory robots at a retail store. They are the ones setting up the cameras so that they can do better scanning, and those don't necessarily have to have college degrees to do these jobs, but you do need to have a technical aptitude. So that's a gap that the U.S. government has identified. That gap exists everywhere in the world, is that tech jobs are growing so much faster than non-tech jobs, and we need our students to have those skills to fill these jobs.
So I guess this is kind of a big picture perspective where you're trying to think of where the world will be in the future, and you're trying to make it so that this need that keeps growing, that we can kind of match it by exposing more people to robotics, getting them interested, even if it's even if it's not like PhD in robotics or like elite researcher or robotics engineer, but just
I think your audience has probably heard of the Industry 4.0, the fourth industrial revolution, right? That it's rapid technology and stuff like that, and that's where we are right now. And I like to think at the REC Foundation we were slightly ahead of the curve as far as developing programs for the fourth industrial revolution, right? For Industry 4.0. But it's not in the future anymore. It's here now. Smart factories are here now. Artificial intelligence is here now. Data learning is here now. All those things are here. When you type in something in your search bar and all of a sudden it does a profile on you, those are technology jobs. That is the the Industry 4.0, and so we need to make sure that we're not preparing students for the future jobs. We're preparing them for the jobs that are here now, and it's just going to continue to grow. And again, it's not just factories, it's just not manufacturing, it's agriculture. For example, I mean, if you've ever gone into a dairy farm, and I've been to many, many dairy farms growing up in rural Pennsylvania, they have some of the most advanced technology, and it's been there forever.
Huh.
I mean, they would, are the cows
so
being
cool.
fed right? How's the quality of the milk and stuff like that? And of course, military, right? The military's high tech now. We're very, very proud that the JROTC, Army JROTC, chose the REC Foundation to be one of their partners. And it's not about people joining JROTC as engineers. It's about these students building our robots, programming our robots, building our drones, flying our drones. There's giving them the basic skill set. So when these students enlist in the military, they have the skill sets to use the modern tanks and to do all that type of stuff. We're here now. Industry 4.0 is here now, and we're just one of many organizations out there that are trying to make sure that our students are ready. And I think that because of our model, we keep prices affordable and accessible. And I think we have a really, really good model, which is why we're growing so quickly.
What explicitly, in terms of skills and how explicitly do you see the REC program contributing to preparing people for the jobs you were mentioning, like maybe setting up a camera or whatever it might be?
So I do think in our program you learn some hands-on tech skills. I do. I think you learn programming. You learn without even know you're learning math. You're learning about gear ratios and torque and some of those things. So you're learning some technical skills. But what our program really, really does, in my opinion, and many programs like ours, is we're really teaching the soft skills. And you hear more and more people talking about the soft skills, but our data shows that students coming out of the program know the soft skills. So let me step back and say what that is. So students that are in our program really learn how to communicate. To be successful in our program, you have to communicate with your teammates. You have to communicate to your coach, and you have to communicate with the teams you're playing against or for. So you learn communication. You learn problem solving and troubleshooting. I mean, that's a skill set no matter what you do. In our program, you are learning how to troubleshoot and to solve problems, and I think that's really, really key. And you're learning the perseverance, and you're learning patience. So all these skills aren't necessarily technical skills, but they're what employers really, really want. I used to hire lots of engineers. I didn't always hire the engineer that had the highest GPA. I hired engineers that were good communicators and good problem solvers, because I could teach them the tech skills, right? I could teach them that. But I really had a harder time teaching people how to communicate and troubleshoot and stuff like that. So I feel with very strong confidence, and the data shows that the universities that study our students, the data shows that students in our programs come out with advanced soft skills. They really are good troubleshooters, good communicators, good problem solvers.
Yeah, it's funny to me. It's almost ironic in a sense that it's so the mission is to increase STEM engagement, and then the big outcome is increasing soft skills, which is not exactly STEM to me, but very, very important.
Yeah, that's very insightful. And in 4.5 years of doing these, you're the first person that's pointed those out. And internally, my own staff has actually stepped back, and I do think you'll see us tweak our mission and vision to emphasize that more. And there's a lot of other robotics organizations out there. I joke that we're the largest, but we're not the best known. But I would say that all the other robotics organizations out there would all say that the STEM skills is what the students get most from our program. I mean, literally the data is in the 90%. You talk to coaches, you talk to parents, you talk to employers, and 90% of our students have good communication skills. 97% demonstrate problem solving. The data is remarkable, and we can teach a lot of the skills, but giving them that infrastructure, that foundation of the good problem solving and communication skills is so important. And again, I don't want to hand wave I joke, how many students in our program learn about 4-bar link systems and gear ratios and torque? They do learn technical stuff too. And, and then if you do drones, if you're in any one of our drones programs, you're learning a lot about physics and aerodynamics and lift and stuff like that too. So
Yeah, definitely. Not to, well, kind of to play devil's advocate, but not to, I don't know, just out of curiosity. Is robotics the best way to teach these soft skills, or why is it well suited for this? If
I
that's
think
kind
it
of like
is.
one of the big underlying value adds of this kind of structure.
Yeah, and I have been asked that question before. And first of all, you'll never hear me say robotics is the only way to do it. I mean, if I would have felt that way, we wouldn't have started drones programs and we wouldn't have started our factory automation competition, right? So there are other programs, but I think the reason that robotics is so effective and the reason that there's other robotics programs out there is because you start with a concept. You have a challenge that you're trying to meet and you start with a concept. So then you design and you build. But then you start competing, and whether you're competing with somebody to score points or whether you're competing against somebody to truly win and lose, it brings up the fun part. And I think sometimes we don't talk about the fun part. And that's why robotics is so effective at doing this, because it's a lot of fun. If you go to a robotics competition, kids are dancing and laughing and making friends and stuff like that. So that's why I think robotics is one of the great platforms to teach these skills. It's not the only one out there, though. I think people that tells you that it is aren't being genuine. But I do think it's one of the good ones. And honestly, with the REC Foundation, our price model is good too. We offer all the educator resources for free. If you go to our website and you want to know how to teach gear ratios, we have STEM labs available for the teachers to learn this. And
that's really nice.
And so that's really, really important, is to make sure that the entry level. I mean, we have what we call educator training, and it's not to teach the teachers to become roboticists, right? It's to help them get over the intimidation factor so they're not afraid of it, right? So, in our program, the teachers really just need to be facilitators. Because the students will embrace the technology, and students are ingenious, right? They go onto YouTube. So if there's an early season competition in China or Singapore and Australia, man, when school starts in the US in mid-August or early September, these students have already scoped out some of the good robots from other countries. And honestly, people say, well, don't you have a convergence of design? And in some of our games, we do get a convergence of design, right? At the end of the year, a lot of the robots look the same, but that's real world too. I spent 21 years at Fanuc Robotics, and a 6-axis robot that does palletizing or does welding or something like that, they kind of look the same. I mean, they look a little bit different here and there. It's what's behind the scenes. It's the kinematics and it's the sensors and the speed that really make the difference. So I don't really care that much that the robots start looking the same after a year. It's real life. But those students that have figured out how to program better and how to utilize their sensors better, they're going to probably have the top performing robots.
That's very interesting. Yeah. Can you tell me a bit about the pandemic and like how you use simulation in all of this?
Yeah, so we made a decision during the pandemic that we weren't just going to become virtual. Now, VEX did an incredible job developing virtual resources. Their VEX code and teaching kids how to program and their virtual robotics that they gave to the community were for free were amazing. That was for so many teachers, for hundreds of thousands of teachers out there, and for the millions of students that learned how to program during the pandemic because of virtual, that was a lifesaver. But at the REC Foundation, we firmly believe that hands-on is part of our program, that it's not just virtual. And there's a lot of companies out there that have transitioned. They're like, you can virtually build a robot or a drone and compete virtually. But we actually believe the design process, which includes building a robot. It includes using the tools, using your hands, putting things together, things breaking is vital. So while we offered virtual programs, we really went for a remote strategy. And since so many, when you have a program as large as we do, there's VEX parts all over the world, right? So teachers found a way to get the parts to their students, and they built robots, and we connected them. You did have to have a field, but we also made it a very simple do-it-yourself field that you could build with plywood. and then you needed a camera, but most laptops have a camera, and we basically developed the infrastructure to connect these. So one of my favorite things in my entire career, definitely one of my favorite parts about 2021, was we had live remote VEX Worlds. So we were still at the point of the pandemic where people couldn't get together in large. So we had a lot of in-person state championships even during the pandemic, but we couldn't have a VEX Worlds with thousands and thousands of teams and tens of thousands of students, right? So we did this live remote technology. And one of my favorite days is I was watching a match, and we had this big screen set up, and we had 6 divisions. And in the divisions, we had I think it was 16 different countries represented. So you saw a team in China playing a team in Texas, and a team from Japan playing a team from the UK. And where the fields were set up was amazing. We had fields set up in bedrooms. We had fields set up in empty libraries. We had fields set up in hallways. We had a field set up in an outside tent in New England where they weren't allowed to have indoor events, in basements and garages, and in some traditional schools too, right? So, and here we are, all these teams were still playing with and against each other because we decided to do it remotely and not virtually.
That's so cool. So I agree with you, but why hands-on? Like, what's the big reason for that?
And I probably need to get some data behind this too, although I know we have it, I just don't have it handy right here. But I think the hands-on reinforces the learning. So it's easy to say, okay, I'm going to put 2 different gears together for speed or torque or power, and you do it in software or you do it in CAD and stuff like that, and you see it that way, versus when you actually do it on a real robot and you put them together and then you change a gear and it goes faster or slower or it's stronger. So I think it demonstrates what you're learning in the classroom. I don't think project-based learning is fundamentally what I believe in, hands-on learning, because you can learn it in the classroom, and then when you do it, reinforces what you learn.
Yeah, I totally agree. I think from my perspective, one of the reasons I really like programming is because I can try things very quickly, and I can immediately see where my idea is not complete. But I think that took a while of learning how to program. But if you're playing with gears and things, or you're trying different things, you can immediately see if the results are working. Like if it's doing what you expect, and if not, that's a great opportunity for learning. So intuitively, it seems to me that hands-on is probably the best way for learning, and probably the best way for getting everyone involved, because the results kind of speak for themselves, and it's not that you have to follow an abstract programming language that is hard to understand for people who are beginning. So physical makes sense to me.
Yeah, I absolutely agree with you. And coding is a great way, because I actually started my career as a controls engineer, so I've done a lot of programming myself. And in our program, we have the autonomous. So even in our elementary programs, we don't start the matches with autonomous, but we have a programming factor. So 1 minute, it's 100% programming based. But what a great way to learn programming. You build your robot, and say you need to go, shoot some balls without driving it, right? So you learn a sensor, you scoop up the ball, and you shoot it, right? And the fact of developing your mechanism is the mechanical spot. The electrical is the sensor, but the programming is how you make it all work together. And whether you just say, go forward for this distance or go forward at this, or whether you actually use the sensors, it's an iterative programming. And I think the programming skill set from our students is the one area I've seen the most advancement. The skill set of programming from 4 years ago when I first joined the REC Foundation, that's the biggest area of increase I've seen.
That's so interesting. Yeah. So one thing that I haven't heard much in the whole program is any open source related things, or use of, you mentioned that you have libraries involved with the coding, but I imagine that they're developed by VEX, or it's kind of like a closed source kind of.
And so our program tends to be a little bit more closed source, but that doesn't mean we don't have open source. Libraries is a good example. The community will develop libraries and share them, and that's a good example. Open source on CAD designs, for example, and some things like that. But we're not giving out the the designs of the motor so that you can design your own motor, for example. And we do that for very practical reasons. One is level playing field. In so many STEM competitions, the more money you have, the better you're going to do. And by everybody starting with the same parts, it does level the playing field. Now, I'm not naive. If you have more funds, you can buy more motors, more sensors, build more iterative designs and stuff like that, and you're probably going to, at the end of the season, maybe have a better robot. But the concept of using one manufacturer's product really does level. The other thing is it keeps the cost down. It really, really keeps the cost down because we're talking volume here, right? So if every robot out there is using 8 of the same motor and we have 30,000 teams, you're mass producing those motors. If it's open source, it's true you might have somebody comes up with a lower cost motor for one application, but overall it's going to be a more expensive product by the end of the season. And there's a lot of robotics competitions out there that are open source and they say it's cheaper, but when you talk to the teams, they ultimately spend way more money in the end.
Interesting. I would wonder also just, and maybe this is the students being a little too young for this kind of thing, but I feel like to really get a lot done, it's very useful to understand how to work in the open source software world, where you can go and grab this one thing, learn about it quickly, and then integrate it into what you're doing, and then grab this other thing, and you can see the value of testing and all of the, my Siri going off, it's just, there's a lot that is very useful to learn there that's very practical, I think. And I wonder if that would be something that'd be useful to fold into the education for the students.
And I think we have that with libraries already, right? So, a lot of times the people that are providing libraries are just providing a compiled version and maybe not the open source code, although most do, right? But at the end of the day, with VEX code, you can develop in blocks and then you can switch it. You can actually switch it over to text and see how the code works. And to me, there's no better way to learn programming. I wish I would have had that in the 90s when I got started, right? So back then it was pseudocode, right? You did pseudocode and then you wrote code behind it. Well, you can pull in a library and if the source code is available, that you can see how it works. So yes, there's a practical reason to use the VEX code, but you're still learning C++. You're still learning the languages out there. Again, this goes back to, because I have these discussions a lot, and I do understand both sides of the argument, but for our program, it's the bell curve. And I remind educators, I remind my staff all over again, it's like we're not appealing to the top 10%. We're trying to appeal to the entire bell curve. And I think the way the model of our program is actually the most approachable and sustainable model for most students. And my kids did robotics. I have 4 children. 3 of the 4 did robotics. 2 of them did VEX, and 2 of them did other programs too that had more machining involved, for example, and stuff like that. And they had the resources at their schools to do it, but they also had much, much larger budgets. They had engineering mentors, computer science mentors. Our program is so that the teacher, the classroom educator, or the parent can be the coach, and the resources are free. So by having everybody start from the same level playing field, it really works better for reaching more students. But I don't pretend that our program, for some of those very advanced competitions out there, that we're offering that same level of engineering. I've never, pretend that we do. Again, but when you look at the 1 million students in our program, I think we're reaching more students.
Definitely. Yeah, it makes sense. Because you're trying to basically supply the most, it's your mission. You're trying to get the most people interested in STEM.
Correct. Exactly. Yeah, you just said it for me. Thank you so much. Exactly. So
it makes sense. Your approach makes complete sense given that mission. And it's nice to see you guys be very mission driven, that informs a lot of your decisions.
Yeah.
So now tell me a bit about your background.
Okay. Well, so I have a lot of passion for rural and underserved communities because I grew up in rural Pennsylvania. I was, definitely solid middle class, but I grew up, we had 30 acres. A lot of my neighbors had 10, 15, 20 acres, but I was a country boy. My high school was 18 miles away. I was in a graduating class of 180. But I was really good at math and science. So I had a teacher that said you should look at going into engineering. I'm from the part of Pennsylvania where Lee Iacocca, and maybe much of your audience won't know who he was, but he ran Chrysler. He was at Ford, and he went to Chrysler, and he turned around Chrysler from bankruptcy. But a lot of my friends that I grew up with, that we built dirt bikes and tree forts and stuff like that, they went into skilled trades, right? They became machine tool operators. They became HVAC technicians. They became diesel mechanics. And I was the only one who really went to college. So at that point, I never felt that to have a successful career, you had to have a 4-year degree. It just was I had the aptitude, and my parents were able to help me out some. And so I went to college in Michigan. I went to, at the time it was called GMI. It's now called Kettering University. It's in Flint, Michigan, but it was a co-op school. And to this day, it's the only full-time co-op university in the United States.
What does that mean?
So co-op means that you would go to school for 3 months, and then you would work for your sponsor, which in my case was General Motors. You worked for 3 months. So you did that for 5 years. So it was a 5-year program, 3 months of school, 3 months of work. It was year round. We used to get a week off for Christmas and a week off in the summer. And so yeah, I've been working in industry since before I was 18 years old. But with the co-op program, your freshman year right out of school, you don't have a lot of skills, but you're already working with very professional engineers. And I worked for General Motors, CPC, Chevrolet Pontiac, the Canada division, for my entire co-op career. And I was doing very advanced projects by the time I was a junior. And so my junior, senior, and my thesis year, I was really, really working on that stuff. So when I graduated, GMI Kettering graduates tend to get really good starting salaries because we have so much work experience. And I was at GM, and a friend of mine was at Fanuc, and he says, Fanuc needs controls engineers. I'm like, well, that's not my background, And he's like, yeah, but you were like the best coder in our fraternity, right? He's like, you were the one everybody answered it. So I'm like, yeah, controls is a lot of coding. So I went to Fanuc as a controls engineer. I traveled the world. I went to factories in dozens of countries and learned control systems. And you do that for 7 years. We started raising a family. My wife says it's time to be home more. I went into project and program management and started developing the next generation of robotics. And I was fortunate enough to be on a couple of patents. My expertise was pneumatics, believe it or not. That was kind of where I really thrived, controls and pneumatics. But I did that for 5 years, and then I started doing the management train. And so by 20th year at Fanuc, I had been director of product development for 5 years. So I had mechanical engineers and electrical engineers. They all worked for me, application engineers, and we were developing great, great things. And we were doing AI, and we were learning about collaborative robots. But I was getting really tired. I did a lot of traveling. I went to a lot of factories, and a friend of mine was down in Texas. He said that they were looking for a president of a company called Rack Solutions. He said he thought I'd be a good fit. I traveled to Texas. I got the job, and I went from high-tech, very advanced robotics to sheet metal design and manufacturing. But it was one of the best things that could have ever happened to me because I realized how important manufacturing. I mean, we always hear that manufacturing is important, and Fanuc had an initiative called Save Our Factory. That by using robots, you were actually keeping the factories competitive so that we could compete against the rest of the world. Well, here I was in a sheet metal company competing against China and Europe and stuff like that. So it was a great experience for me. I started learning the business side, P&Ls and stuff like that. And I started coaching robotics. And so I started coaching robotics, and my good friend was the president of VEX Robotics, and because people knew that we were friends, they started saying, hey, go tell Paul this, go tell Tony this, go tell Bob this, right? And so I kept going to those guys, and I kept saying that, hey, this is some of the feedback we're getting from the community. And finally, I think I must have frustrated them. They're like, you need to join our board. So I joined the board of the Robotics Education and Competition Foundation. I dug in really hard for 6 months because, I've been hearing what the community thought of it, right? And I thought we could do better. So after a couple of months, I gave a report to the board on things I thought we could do better financially and organizationally and product-wise. And the board asked if I would take over as CEO. And that was 5 years ago. in June. So the first week of June, 5 years ago. And it's been fantastic. And as I started the conversation, I was happy to take the job. I had my doubts because I'd never been for not-for-profit. But I said I wanted to have the ability to work on workforce development, not just be STEM. And I wanted the ability to branch outside of just ground robots too. And the board was kind enough to say, sure, go for it. If you have time, go for it. I think they thought I'd be so busy with the VEX Robotics competitions, I wouldn't have time, but we've built up a really good staff here and we've expanded. So 21 years in industrial robotics from the controls side to product development, and I've gone full circle to now robotics education and competitions.
It's quite a path.
Yeah.
How do you see programs like yours, like REC, helping, or how does it fit with the educational program in your mind?
Yeah, I think we're really complementary. I think, again, because of VEX and For the Win and Bell and so many of our other partners, they developed curriculum content. But I firmly believe that to reinforce what teachers are teaching in the classroom, especially technology, pre-engineering, physics, math, you can teach it in the classroom, but like we talked about earlier, when you can demonstrate it and have hands-on, it reinforces it. And it goes the same way. You can't just start a robotics program and just build robots. It's complementary to your math programs and stuff like that in the classroom. So I think we really work well. One of the things we can do at the REC Foundation, one of the huge values that we have is when I first started the REC Foundation, we gave out grants, but it was always equipment grant. That was the only grant that you got from the REC Foundation was a robot kit, right? But we've listened to the teaching community, the education community, and they need more than that. They need resources. And the beauty of this position is we've been able to go to the Northrop Grummans and the Googles and the Teslas, and now we're able to get funding for them for stipends and for other resources. So now we can go back to the teachers in the classroom and we're going to if you're going to do a robotics team, we can give you $1,000 or $2,000 and we can give you other, continuing tech training and stuff like that. So we don't just give kits anymore. We still give a lot of robot kits out as grants, but we give out so much more. And that's where we really complement each other. Because let's face it, in the United States, football coaches, basketball coaches, they all get paid stipends to be coaches. Why not robotics coaches? And I think between us and other organizations, we're really challenging that. And there's been a huge increase in our sponsors and government grants giving us money that we can give stipends to robotics teachers.
That's really awesome. I like that idea a lot. It's, it definitely makes sense. It's crazy if it's basketball coaches and football coaches getting stipends, and then the robotics team. Especially if you're bringing in someone who's having to learn these things and be very involved, or it's very nice if they can get a stipend too to just kind of help out with it. Because it might be at the expense of other areas in their life too.
No educator's getting rich on their stipend, right? But
I guess
the thing is, we don't want them to cost them money, right? So I'm sure most of our stipends just cover the gas and the pizza and the spare parts that they buy. And nobody's actually increasing their net worth because of the stipends, but at least it's not costing them the money. And again, it just doesn't, as the United States, for us to continue to evolve. And of course, we're a global foundation, so all the world, but particularly in the United States, you see a difference. People ask me geographically what's different about teams in the Northeast or the South or the Pacific Northwest. Well, there's a lot of programs in the Northeast that have been paying their robotics coaches and teachers for a long time, right? And they're very stable and they have excellent students. And then you have emerging areas in the United States that never thought about paying a robotics coach. They never even thought about having a robotics team. Alabama is a great example. When I joined the REC Foundation, there was probably 100 teams in Alabama, and it's almost at 1,000 now because Our staff really did a great job of working with teachers and educators, and then the Alabama Department of Education started investing money. The first year it was $250,000. This past year, $850,000.
Wow.
And other organizations in Alabama started, Hyundai, again, not a sponsor to the REC Foundation directly, but Hyundai is making sure that every elementary, middle, and high school in Montgomery, Alabama has a robotics team. And you have SCORE is making sure these teachers are getting their training, and the Department of Education is giving stipends. So they all build together, and now Alabama has got an incredible robotics program. And guess what? There's a lot of factories in Alabama, a lot of automotive and other factories, and they need these students. So some places have been committed to doing this for a lot longer, and Michigan's an example of a state that's had robotics programs for 25 years, and you have other parts of the country that are just starting to get into it.
What do you, so you mentioned that there were a few schools that were adding this into the main curriculum, not just as an extracurricular. Can you tell me a bit about that?
Yeah, sure. And I would say that pendulum is really increasing. Maybe 5 years ago, 10%, and it's at least 30% now. Matter of fact, I was at a competition.
30% of schools you're at?
Or? Yeah, schools. The schools are actually, whether they call it in manufacturing or whether they call it engineering or technology. I mean, I've heard all of them, right? So a technology curriculum. But I was at a competition this past weekend, and the top teams there, if they start as freshmen, they can take technology, and then they take technology 2, then engineering 1 and engineering 2. And they meet every single day, just like you do for history or English or whatever. But they have their technology class, and they use VEX, and they start by building simple mechanisms, and then they learn about motors, and then next thing you know, you're a sophomore and you're building more complex stuff. And because they do it every single day for an hour a day, by the time they're senior, these kids are really, really good. And most of them are actually going and getting engineering degrees. But I know one student that has a job at John Deere lined up. He's going right to John Deere out of high school, right? He's going to get his industry certification and go. And Tesla has similar programs, right? Where some of these students, why go into debt, right? Why go work for Tesla or John Deere, and they'll pay for you to take classes at your community college or your 4-year university. So they're paying for you. They're paying you a salary to do the job, and they're paying you to get your certifications and your degree. And next thing you know, you have a 2 or 4 year degree. But back to your original question, schools themselves know that we need to do a better job for the students and make sure they're prepared for the workforce. So more and more more and more schools are investing in technology. It's kind of full circle. When I was in high school, we had vocational programs, the HVAC, the machine shop, etc. And then we got away, and then we said everybody needs to go to college. And now we're kind of going back and saying, man, all these people that repaired our air conditioners or did diesel mechanics, they're all getting ready to retire. We have nobody coming behind them. So these schools, the governments, they're reinvesting in these programs. But now it's not just HVAC and diesel mechanics. Now it's robot technician, etc.
That's really
so we at the REC Foundation, we just work really, really closely with these educators so that they have the tools so that they can bring these programs to their classes.
What do you think you think the future of education is that, or future of universities will be that fewer people go to actually get like a bachelor's of science in something, and maybe more people, it would be more like, say, some places in Europe that have more vocational schools and this kind of thing. You think that education will start to lean that way?
Yeah, I think the data is trending that way. I'm going to be really careful here because we have a lot of university partners, right? A lot of great universities we partner with. But I think we're already seeing declining enrollment in so many schools. And it's not a secret that they expect a lot of colleges and universities to fail in the future. Because the problem is it's just gotten so expensive, for students to go. So I do think you're going to see these alternative career paths instead. Again, the externship program that Tesla did is a great model where you graduate, you start the program when you're in high school, and you get experience working on the factory floor. You're working in the shops. You get paid. And then again, if you want to go get an industry certification, they pay for that. Then you start taking classes at a 2-year school. I think you're going to see more and more organizations do that. And I think you're just going to see people make financial decisions that make sense. And I think there is going to be some type of consolidation. And I think our universities will step up. And I think our community colleges are fantastic in this country. It's really one of those gems that we have that the rest of the world doesn't, because maybe we don't have tech programs in high school like they do in Europe, but we do have these community colleges, and we have a lot of programs, that are supported in community colleges. And that's a good way for students to get this skill set.
Interesting. I know very little about the community colleges and what kind of things they offer. But you're saying it helps people get vocational skills, or?
Yeah. I mean, you get your, in some paths you get your baseline to go to a 4-year university. You get your general classes out of the way. You get your math, your sciences, your history, and like in Texas, if you go to an accredited community college in Texas, the 4-year universities have to take those credits, right? And there's a lot of states that have similar programs. But so many community colleges that we work with now have industrial automation or technology programs where they're literally teaching the skills. And after 2 years, these students earn certifications and then they go get the jobs, right? So community colleges are really, the government, Department of Defense is investing in community colleges because they know that's a really good way for us to train our workforce.
Interesting. Yeah, it makes complete sense. So we're beginning to wrap up. What do you think for kind of the future of education and programs like REC? Do you think it'll be enough for all of the help? Like, will we be able to provide a good number of workers for the shortages, or just how do you think of things going forward?
Well, we're going to make a dent, if nothing else, right? We're going to make a dent. We're going to help. And the REC Foundation, we have a lot of great programs. There's other great not-for-profits out there too. And you have Apple is investing in their own education programs, and there's other companies that do it. So I think if collectively we all work together, we are going to address the issue. But it's going to take some time. It's going to take some time to retrain our teachers, so that they have the skill sets to teach this. It's going to take time for our industries to adapt to a different type of model, how they employ their employees. I don't want to get too philosophical here, but students in this country prefer playing sports and prefer doing video games and stuff like that, and I've been fortunate. I've traveled across the world. I've been to over 50 countries, and there's other cultures where they emphasize academics and especially tech, and we're not there in this country yet. So it's going to be an entire culture shift between education, between the government, between private companies, public companies, and not-for-profits. We're all going to have to work together, and there's great organizations out there, like, the REC Foundation belongs to ARM out of Pittsburgh, Advanced Robotics and Manufacturing, and they do a great job of bringing government, private industry, 4-year, 2-year, and not-for-profits together to tackle this problem. So.
Awesome. Do you have anything to share for people that are interested in either getting involved as students or interested in getting involved as someone who facilitates it, or just learning more? Any resources?
Yeah, the easiest thing to do is I always ask people, go to our website. It's roboticseducation.org. Again, roboticseducation.org. And on the landing page, it's like, are you new to robotics? And you just navigate the website. VEX Robotics, they also have a great website for educators. They just have so many amazing resources that are for free. So go to VEX Robotics or go to roboticseducation.org. Those are always good things. You can always Google, how do I start a robotics team? And our website has those responses. That's the best way to do it. On our website, we have a map of the world, and literally when you click the country, it tells you who the REC Foundation person for that country is. Or if you click the state, it tells you who the event side is and who the team side is. And then we have things like online challenges too. So maybe this year one, you don't want to jump into starting a robotics team. but you can do online challenges, and some of them are like CAD based, some of them are about diversity and inclusion programs like Girl Powered, but there's different ways to do it there. And then there's also grants. We know that cost is a barrier of entry, so we have an entire page on grants. And then for the students out there, the RIC Foundation gives close to $60 million. Well, we don't give it directly, but our university partners give $60 million in scholarships for students. So all those resources available by the website. So if you're an educator, come to our site or go to the VEX site. If you really want to learn about starting a team and how we can help you in the classroom, go to our website.
Awesome. All right, it's been a pleasure speaking with you.
I've enjoyed it so much. And again, if anybody here wants to reach out to me directly, my email is Dan_Mantz at roboticseducation.com. And I always respond. Sometimes I don't get to it in the first day or even the first couple days, but I'm always happy to reach out. I'll see if I can show this on the camera real quick.
I can add it to a link.
It's backwards, but it's roboticseducation.org. I just realized I said com. So Dan_Mantz at roboticseducation.org. And me or someone from my team will be happy to help you navigate, which at times can be terrifying, but I guarantee you it's rewarding. If you talk to the people that are involved in our program, they'll tell you we're really making a difference and it's really rewarding for them.
Awesome. Thank you, Dan. Bye, everyone.
Bye. Thank you for having me.
Thanks for listening to this conversation with Dan Mantz. Thank you again to our founding sponsor, Open Robotics. See you next time.